What is geological carbon sequestration? Have you ever wondered how we can tackle climate change while still using fossil fuels? One method that has gained attention is geological carbon sequestration. This process captures carbon dioxide emissions from sources like power plants and stores it deep underground. The goal is to keep this greenhouse gas from entering the atmosphere and contributing to global warming. The journey begins at industrial sites where carbon dioxide is produced. This gas is captured, purified, and compressed into a dense state. Think of it as turning gas into a liquid-like form that can be easily transported. Once it is ready, the carbon dioxide is sent through pipelines to a designated injection site. At this site, the carbon dioxide is pumped down into porous rock formations that lie thousands of feet below the Earth's surface. These formations, often made of sandstone or other permeable rocks, have tiny spaces that can hold large amounts of carbon dioxide. Above these layers is a dense rock layer known as caprock. This caprock acts like a lid, preventing the carbon dioxide from escaping back into the atmosphere. The carbon dioxide can remain trapped in these underground formations for a long time. It may also dissolve into fluids or even turn into solid minerals over time, providing an extra layer of security. From an anthropological viewpoint, geological carbon sequestration connects with human behavioral ecology and resource management. It shows how societies respond to climate change while managing their natural resources. This method reflects a technological adaptation that allows us to continue using fossil fuels as we transition to cleaner energy sources. However, this process is not just about technology. It also involves social and economic factors. Local communities often need to accept these carbon storage projects. There are also questions about how underground resources are governed and how the benefits and risks are shared among different groups. In practical terms, geological carbon sequestration is already in use in some industries. For example, in enhanced oil recovery, carbon dioxide is injected to help extract more oil while simultaneously storing it underground. This technique plays a role in climate change strategies, helping manage carbon emissions from existing infrastructure. Overall, geological carbon sequestration illustrates the relationship between human activities, technology, and the Earth's geological systems. It highlights how societies shape and manage environmental processes to tackle global challenges. Understanding this method helps us see the potential pathways for reducing carbon emissions while still relying on fossil fuels during our transition to a more sustainable future.